Alrighty, ladies and gentlemen, it's exam time for pre-calc functions. So we're going to start off with Unit 1. This is our functions unit. This is a long unit. So first thing I'm going to do is I'm going to find a difference quotient. So if it says f of x is x squared plus 1, I need to evaluate this. So a plus h squared, that's f of a plus h, minus, and when you subtract, you need to subtract a quantity. F of a would be a squared plus 1. So now that's over h. And I'm going to need to simplify. So one big thing here, when you FOIL this, you do not just distribute exponents. That doesn't work. You need to write it out. 2ah plus h squared minus a squared, and then minus 1 when you distribute the negative. So that's all over h. Now we're going to combine some like terms, and hopefully a lot cancels out. So that goes away, and a squared goes away. So I have h squared plus 2ah over h. And now I can factor in h out of the top, and I have h plus 2a over h, and these will cancel out, and you're left with, I'll write it 2a plus h for the difference quotient. Second one, solve the nonlinear inequality. First thing we need to do is get everything on one side, and then we're going to make a sign chart. So when does this greater than 0? So we're going to factor it, and that's x minus 7, x plus 4, and this gets us sort of points of interest at 7 and negative 4. So I'm going to draw my number line, and I'm going to put negative 4, and I'm going to put positive 7. And first thing, does negative 7 actually satisfy this inequality? If I plug in, 7, then I'm going to get 0, and 0 times whatever is 0. So is 0 greater than 0? The answer to that is no. It is an open circle. If this was a greater than or equal to, these would be closed circles. So now I have my points of interest. Now I need to test points along the number line. So let's pick a number that's way smaller than negative 4. Let's pick negative 100. If I plug negative 100 in right here, I'm going to get negative 107. If I plug negative 100 in here, I'm going to get negative 96. So a negative times a negative is going to give me a positive number. If I pick a number between negative 4 and 7 like 0, 0 minus 7 is negative, 0 plus 4 is positive, and I'm going to get a negative number. Then if I pick a really big number like 100, 100 minus 7 is positive, 100 plus 4 is positive, and those will multiply to a positive. So what I'm looking for on my number line is where the number line is greater than 0. Sorry about the bell. Greater than 0 right here. These are the positives. That's positive, and this is positive. So when I want to describe my solution set now, I'm going to say all these numbers, so negative infinity to negative 4, those are both parentheses, and over here, 7 to infinity. So now I've got my solution set. Let's move on. How will we move the graphs? We're talking about transformations. If you're inside the parentheses, x minus 2 is going to go right 2. Outside, when you subtract, is down 2. When you multiply, this is going to be a vertical stretch. So a vertical stretch times 2. The y coordinates are going to get doubled. Here, you're going to reflect over the x-axis. So for example, if it was like this, and I made it negative, it would go upside down, and it's also going to move up 3. So this is going to get reflected over the x-axis. All the y values are going to get flipped, and it's going to move up 3. This one is going to get reflected over the y-axis. So if that was my function and I said, okay, f of negative x, it would look like that. So this is getting reflected as well, but it's over the y-axis. Down here we have to go, first thing we're going to go right 3, and we also have to do another vertical shrink this time, so it's going to be all the y coordinates get multiplied by 1/2, so it's going to be a vertical shrink instead of a stretch. Piecewise functions. The name of the game here is figure out which of these three pieces you need to use. If it says negative 3, I got to figure out which of these negative 3 belongs to. So negative 3 is less than or equal to negative 1, which means I'm plugging it in the first one. Negative 3 squared plus 2 times negative 3. That's 9 minus 6, so 3. Second one, f of negative 1, that's less than, oh no, hold on. Right here, negative 1 is less than, so actually I'm in the same one still. So I'm going to plug in negative 1 squared plus 2 times negative 1, and 1 minus 1 is negative 1. F of 0, so 0 is between negative 1 and 1, so if I plug in f of 0 into x, I'm just going to get 0. F of 1, 1 is greater than or equal to 1, so I'm using the second one still, x is 1, and f of 2, 2 is greater than 1, so this one is negative 1. So you got to pick the right piece, and then you just evaluate appropriately. For the function, find the average rate of change. Average rate of change is basically you're thinking slope, guys. You need to figure out f of 0, and you need to figure out f of 5. F of 0, 0 plus 2 is 2, 2 squared is 4. f of 5, 5 plus 2 is 7, 7 squared is 49. I'm doing change in y over change in x. So the change in y is 49 minus 4, and the change in x is 5 minus 0. So this is 45 over 5. The average rate of change is 9. Next up, we're going to convert to vertex form. So here we're going to need to complete the square. When you complete the square, you want to focus on the first two terms. I'm going to factor out a 2, and now I have x squared minus 6x. And I'm going to put a little blank here, because I know when I complete the square, I'm going to figure out what number I want to plug in there. So half of 6 squared, half of 6 is 3 squared, you get 9. I'm going to add 9 in here, and the reason I'm doing that is because now that's factorable. But I'm not really adding 9, because this 2 is on the outside. So I'm really adding 18 to this side, so if I want to balance this equation out, I need to also subtract 18 on the outside. So now I have 2 times x minus 3 squared plus 23 minus 18 is 5. So now my function is in vertex form, and I could tell you real quickly that this thing has moved right 3 up 5, so the vertex is at 3, 5. What else we got? Let's try find the domain. So find the domain, I'm looking for, I see a square root, and I immediately know, oh, you can't take the square root of a negative, so whatever's underneath the square root has to be greater than or equal to 0. You can take the square root of 0, it just has to be greater than or equal to 0. Now I'm going to factor this, so you can do split the middle, but this one's pretty easy to guess and check. I want positive 4 and negative 1. So I need those two numbers, and now I'm figuring out where those things hit the x-axis, and that'd be 1/2, and that'd be negative 2. So as long as I'm not picking those numbers, I'm good. Let's draw a number line and kind of map this thing out. Ooh, that's not straight or horizontal. So now what I need to do is I'm going to put those points of interest on my number line. So I'm going to put negative 2, and I'm going to put 1/2, and I'm going to figure out, first of all, does this work? So yes, negative 2 works, and yes, positive 1/2 works. If I go to the left, what kind of numbers am I going to get? We're testing here again. If I pick a number smaller than negative 2, like negative 100, that's going to be a negative, that's going to be a negative, so this is a positive area. Plug in 0, you're going to get negative 1 and positive 2, that's a negative. Pick a really big number, that'll be positive, so positive, positive is going to give you a positive. I'm looking for where I'm taking the square root of a positive, so on my number line, I want this, and I want that, and now I just need to describe that in interval notation, so negative infinity to negative 2, and this is a bracket this time, union 1/2 to infinity. And it's a bracket because I can take the square root of 0. If I plug negative 2 into this, I'm going to get 0, and you can take the square root of 0, so it's a closed circle bracket. Find the inverse. So we're going to flip x and y, 1 plus 3y over 5 minus 2y, and now I'm going to get this over here, so x times 5 minus 2y equals 1 plus 3y. Probably going to have to distribute here. 5x minus 2xy equals 1 plus 3y. Here's the other bell. Get to class. Let's get all our x's on one side. Oops. Let's subtract 1, and we'll add this. So I added 2x and I subtracted 1.
Good morning, ladies and gentlemen.
And now I'm going to pause this and pick it up in a minute. Okay, so let's pick up where we left off here. I'm going to factor out this y, and I have 2x plus 3, and on the left side, now I have y times this quantity, so I can just divide out that quantity as long as I do it on both sides. And when I do that now, I have y equals, because those cancel out, 5x minus 1 over 2x plus 3. Now since this is an inverse, we're going to write our answer, instead of y equals, we're going to say f inverse of x equals, because the original function they gave us was f of x, and here's the inverse function. Alright, determine if it's a maximum or minimum. So one thing you could do is just graph this thing. You got your graphing calculator. It's going to look something like this. And what I'm going to do is figure out where the vertex is. It's so easy to do, though, in my head. So all I'm going to do, opposite of b over 2a, the opposite of negative 12 is 12 over 2a, so 12 over 6. This gives you the axis of symmetry. The axis of symmetry is 2, so I know it looks something like this on the graph. This is my axis of symmetry. Now I need to figure out where the y-coordinate in the vertex is, and to do that, I'm going to plug in 2. So if I do that, I'm going to get 1. So 2, 1 is the vertex. Hey, that's pretty good. 2 1s right there. You can just graph it and find the vertex, or you can do opposite of B over 2A and plug it in to get the vertex at 2 1. And since it opens up, it is a minimum. The vertex is at the bottom, the smallest y value, so it's a minimum. Find all local max and min values. So first, let's label these max and min values right here. These are local mins and maxes. So -2, -2, 0, 0, 1, -1, and 3, 1. Those are my local mins. These are my local mins. These are my local maxes. And now what I need to do is figure out intervals of increasing and decreasing. So first, I'll do increasing. To find my increasing intervals, what I'm looking for is, where is this function going up as I read left to right? So here it's going down. Here's an increasing interval right there, and here's an increasing interval right there. So those are my two intervals of increasing. Now what we're looking for are x values. So the x value here is -2, and the x value here is 0. And we talked a little bit about whether these should be brackets or parentheses, and we just said, you know what, we'll always do parentheses. So -2 to 0. And then the other increasing interval is from 1 to 3. We're looking at x coordinates. The x coordinate's 1, the x coordinate's 3. So from 1 to 3, that's an increasing interval. I'm going to do the same thing with my decreasing interval. So I'm just looking for where this function is going down left to right. So it starts off moving down. So this is -infinity 2. The x coordinate is -2. And then it goes up. And then from 0 to 1. It's decreasing, and then the last interval of decreasing is from 3 down to infinity. So from 3 to infinity is my last interval of decreasing. Alright, f of g of x, so I'm taking this and I'm plugging it in, so 2 times not x plus 3, but 2 times g of x. So 4x minus 1, now I want to distribute, 8x minus 2 plus 3 is 8x plus 1, that's f of g of x. And g of f of x is, I just go the other way. So now instead of 4x minus 1, I'm taking this function and plugging it in there. So 4 times something minus 1 here, the something is f of x, 2x plus 3. And when you distribute, 8x plus 12 minus 1 is going to be 8x plus 11. So there's g of f of x. Sometimes it's written like that. Either way, g of f or g of f. Goff. Number 12, find the domain. So what we're looking for mainly are even roots and variables in the denominator. So I have an even root, which tells me right off the bat, you can't take the square root of a negative, so x has to be greater than or equal to 0. I'm going to kind of sketch this on my number line just to focus on where we're at. We have 0, and right now I know that I have to pick the numbers that are to the right. So all these are potential candidates. But we'll see if the denominator holds anything for us. Down here, I have to figure out when the denominator equals 0. Because if it equals 0, we got bad news. You can't take the square, or you can't divide by 0. So I'm going to factor this, and I got 2x minus 1 times x plus 1. You can do split the middle if you want, but you're going to figure out that at 1/2 and -1, we have zeros. Well, -1 I don't really care about because it's over here anyway, but 1/2 I do care about. So what I'm going to need to do on my number line is at 1/2, I'm going to need to have an open circle. There's a hole in the graph. You can't divide by 0, so I need a hole in the graph here at positive 1/2. I need all the numbers that are greater than or equal to 0, but I can't plug in 1/2 because then I divide by 0. So what I need to do now is write this in interval notation. So it's from 0 to 1/2. 0 is inclusive, and the 1/2 is an open circle. And we're going to have a union here with 1/2 to infinity. So from 0 to 1/2 and 1/2 to infinity, that's the domain. You pick anything else, you either take the square root of a negative or you divide by 0, and both those are no good. Sketch the graph of the inverse. So easiest thing to do here is to make these ordered pairs. That's -4, 0. This is 0, 4. This is, let's see, what do we got? 2, 1, and 1, 2, 3, 2. And the reason that I'm doing that is if I want to make a list of values for the inverse, I'm just going to flip all these. So instead of -4, 0, it's 0, -4. Instead of 4, 0, it's 4, 0, 4, it's 4, 0. Instead of 2, 1, it's 1, 2. Instead of 3, 2, it's 2, 3. If I plot those ordered pairs, I should have the inverse. So 0, -4 is about here. 1, 2, 3, 4, 0. 1, 2, and 2, 3. That looks like 4. It's 4, 2. So 2, 4. 2, 4. There we go. So now that I have, I missed 2 4s right here. Now that I have my points, I can just draw it like that. So find the original order pairs and then flip them. Make sure you get the original ones right. That's 4, 2, not 3, 2. And then you just flip the order pairs and you've got yourself the inverse function. It should look like, because it really is, it should look like I reflected all those points across the line y equals x. So if I look at that and said that's a reflection, does that look pretty good? Those look pretty good, those look pretty good, those look pretty good. Yeah, I think we got it then. Find the inverse. Again, we're flipping x and y. Whoa, that's not a line. X equals to y minus 5, and I'm going to solve for y, add 5, divide by 2. So y equals x plus 5 over 2. But again, when we're finding inverses, we should write it as such. This is the inverse of g, so g inverse of x equals x plus 5 over 2. Take a breath, we're close. Number 15. Determine the average rate of change again. So what I'm doing is find the slope of the line that connects these points. This is negative 1, 0, and this is 5, 4. So if I find the slope of this line, I'm going to do 4 minus 0, y2 minus y1 over 5 minus negative 1. That's 4 over 6. So the slope of that line is 2/3. We're going to do f of g of 0. So first I'll find g of 0. 2 minus 0 squared is 2 minus 0 is 2. And then I'm going to take 2 and plug it into f. So f of 2 is 3 times 2 minus 5. So f of 2 is 1. So f of g of 0 is 1. Now I'm going to do g of 2. So first let's find g of 2. If I plug in 2, I have 2 minus 2 squared, which is 2 minus 4. So negative 2. Now I'm going to plug negative 2 into g. So g of negative 2 is 2 minus negative 2 squared, which really doesn't matter in this problem because 2 squared is the same as negative 2 squared, and I still get negative 2. F of g of x, so if I'm taking this whole function now and plugging it in, it's going to be 3 times something minus 5, but the something is the other function, 2 minus x squared, so 6 minus 3x squared minus 5 will simplify to 1 minus 3x squared. You could write negative 3x squared plus 1, that's fine too. And then if I want to do the last one, I want to go backwards. So g of f of x, now I'm taking this guy and plugging it in here, where x is, 2 minus 3x minus 5 squared. Now you do need to write that out, and you need to expand it. If you do it in your head, great, but make sure you have the parentheses here. This is 3x times 3x is going to be 9x squared, minus 15 is minus 30x, and negative 5 times negative 5 is positive 25. I'm running out of space, but I'm going to make it. So 2 minus 9x squared plus 30x minus 25. When you expand this, you have to make sure that you subtract the quantity. So I have this whole thing expanded, but I need to distribute the negative. And now I'm going to combine like terms. 9x squared plus 30x minus 25 plus 2 is negative 23. So now I have g of f of x. This is negative 9x squared. So that one took a little bit. I think we got one more. Find the domain, the last one. I don't have any square roots, but I do have a denominator. So I need to figure out when the denominator equals 0. And it equals 0. If you factor, you're going to get x plus 2, x plus 1, which means x cannot be negative 2, and x cannot be negative 1, because if it is, you get 0. So on the number line, if we visualize this, I have holes in the graph at negative 2 and negative 1, but everything else works. In the middle will work, because you can divide by whatever, positive or negative, just not 0. Those work, that works. All I need to do now is write this in interval notation. So negative infinity to negative 2, negative 2 to negative 1, and negative 1 to infinity. And that is your Unit 3 crash course.